Hi everyone, so today I'll be going over the basics of redox reaction, and first I'll go over the three definitions of redox. So the first one, that's kind of in the name, reduction is the loss of oxygen and oxidation is the gain of oxygen. You can also talk about redox in terms of hydrogen, so reduction can be the gain of hydrogen, or the loss, and oxidation is the loss of hydrogen. And I'm sure the one everyone remembers from GCSE, that reduction is gain of electrons and oxidation is loss of electrons. And if you don't know the famous mnemonic, I think that's what it's called, to remember using oil rig. So oil, oxidation is loss of electrons, and rig, reduction is gain. And then the other thing you need to know is the oxidizing agent and reducing agent. And basically all you have to remember that the oxidizing reagent is the one that's being reduced, so kind of have like the opposite thing. So like the one that's being reduced is the oxidizing reagent, and the one that's being oxidized is the reducing agent. Usually when we see redox reactions, they are written in half equations, like these two. And with half equations, it's really easy to see which elements undergoing reduction and oxidation, because we can see the movement of electrons. Like we can see magnesium's undergoing oxidation because it's losing electrons, and that the oxygen is undergoing reduction because it is gaining electrons. However, if we write out the equation in full, like so, and we cancel out the electrons, it can be much harder to identify which element is undergoing oxidation and which one's undergoing reduction. And this is where assigning oxidation states to the elements can be really useful, because then we can see how the number of electrons in each element changes. Okay, so there are 4 main rules that you have to remember to assign oxidation state. The first one is quite simple, that elements in their pure form has an oxidation state of 0, because it's kind of like neutral, so it's just 0. Oxygen in compounds usually, almost always, has an oxidation state of -2, with its exception being if it is in peroxides, and in peroxides, it is -1. And the other one is that hydrogen in compounds has an oxidation state of +1 almost always, except when it is in metal hydrides, because then it is -1 also. And the fourth one is that the oxidation states, the sum of oxidation states adds up to the charge of the compound, compound. So like if it is neutral, like if it doesn't have an assigned charge like magnesium oxide, then the oxidation state adds up to 0. But if it has a charge like -1, the oxidation state has to add up to -1. So then we can use these rules, apply them to this equation above, and we can see magnesium has oxidation state of 0, oxidation state of oxygen is 0, and then oxygen is -2, and as the charge is neutral of this compound, magnesium has to be +2. And you can see, just writing this down without even looking at the half equation, we can tell which is undergoing oxidation and which is undergoing reduction. So that magnesium is undergoing oxidation because its oxidation state increased from 0 to +2. And this makes sense because if you lose electrons, your charge will become positive. And then oxidation is undergoing reduction because its oxidation state decreased from 0 to -2, which makes sense as reduction is gain of electrons, which makes its charge overall more negative. So here I have some practice questions, and another rule kind of rule I really want to add on is that if the compound like this one doesn't have any hydrogen or oxygens, or like this one, you can go with the valency of the element by looking at the periodic table, and that usually is the oxidation state. So yeah, and if in a part of this question, if there is no change in the oxidation state of the element, it is not a redox reaction, because for it to be redox, there has to be a change in the state. Okay, so pause the video and try it out for yourself. Okay, now I'll go over on how to solve it. So bromine is -1 charge, so it's -1. Chlorine is in 0, and then bromine becomes 0, and chlorine becomes -1. So then the bromine went from -1 to 0, so it got oxidized. Therefore, it is the reducing agent, and the chlorine is the oxidizing agent, and it is a redox reaction. So silver here is +1, chlorine is -1, and in the periodic table, chlorine valency is -1. So that means the silver has to be +1 as it's a neutral compound. There is no change in the oxidation state, so this is not a redox reaction. So for last one, magnesium is 0. Hydrogen is usually +1, so chlorine is -1. Chlorine is usually -1. You can usually go with if you want to go with valency state, it's always better to go with like the group 7 or group 1, because group 1 is usually +1 and group 7 is usually -1. So chlorine is -1 times 2, so -2, and the magnesium becomes +2, and then the hydrogen here is the hydrogen doesn't really change. State is 0. So the magnesium went from 0 to +2. So it is oxidized, therefore it's the reducing agent. And then the chlorine went from -1 to -2, so it's reduced, and therefore is the oxidizing reagent, and it is a redox reaction. So in the IB, another skill you need to have is writing out the full redox equations. There's 7 steps. The first one, you have to ensure to balance the elements, except the hydrogens and the oxygens. The other one is you have to add H2O to balance the oxygens. After you balance the oxygens, you add H plus to balance the hydrogens. And the next one, you balance the charge by adding electrons. And then the last one is repeat for the other half equation. And then multiplied equations. To equalize the number of electrons in both equations, so they cancel out. Last thing you do is combine the half equations. So does seem like a lot of steps, but if you think about it, it's quite logical, and the more you do it, it becomes like quite natural. Okay, so here I have two half equations that I want to balance to get the overall redox equation, and this is a reaction between sulfite ions and manganese 7 oxide or permanganate. So first I'll focus on the sulfite ion half equation. So the sulfurs are already balanced, so we don't need to change that. So we can go straight into balancing the oxygens, which if you remember is by adding water. Then after adding water, we want to balance out the hydrogens by adding protons. And then next, you want to balance out the charge. So overall, we have a -2 and +2, so the overall charge here is 0. Over here, the overall charge is -2. And as we balance the charge by adding electrons, then I have to add electrons over here. So now both sides has a charge of -2. So next, we will balance out the manganese 7 half equation. So again, the manganese are balanced, so we just have to add the water to balance the oxygens. So we have 4 oxygens, we'll put a 4 in front of it. Next, we add the protons to balance the hydrogens. So now we'll look at the overall charge. The overall charge of this one is +7, and overall charge here is +2. So we'll have to add 5 electrons to the left side to make the charge even. So just put that there. So the next thing we need to do is multiply. The next thing we have to do is combine them, and to combine them, we want to cancel out the electrons. So we'll just multiply them to cancel them out. So I'll multiply this entire equation by 5 and this entire equation by 2, because then we'll have 10 electrons in both sides and we can cancel that out. And then you can write the whole equation. So have 5, 3, 2 minus, plus 5H2O plus 16H plus. Actually, we know this would be 16H plus. This will be 10. So it would actually be 6H plus, because the 10 will cancel out. 6H plus and 2 minus, then we'll have 5. Yeah, so just have to make sure you're multiplying everything as you write everything down. 5SO4 2 minus plus 2, and then 2 plus and 8 waters. Oh, again, you also have to cancel out the water, so this will be canceled out. Have 3. There, that's the full redox equation. It is quite a lot of steps to go through, but just keep practicing and practicing, and then it'll just become second nature. Okay, so here are 3 more practice questions you can do to practice balancing redox equations, and I'll put the answers in the description. So good luck, and thank you for listening.